Alright, in this video we'll be going through what is voltage. Now, like I said in my video about current, I do believe that some people go into level 3 with gaps in their knowledge about what is current, even though it might seem like such a simple concept. Now, like I said in my video about current, this does not speak to your intelligence or your amount of knowledge, more so how trash NCEA is and how poorly NCEA is taught. So I'm going to try and fix that. Now, I just want to say that these concepts aren't explicitly needed for NCEA Level 3 electricity. You won't be tested on any of these concepts. However, I believe that they are nice to have as background knowledge so you actually know what's happening when we talk about voltage, rather than just memorizing whatever your teacher put on the board, or just memorizing the past exam answers word for word, or calculation by calculation, if you will, and then getting excellence. Even though you can and might have gotten excellence that way in the past, I believe that's sort of a pseudo-excellence. NCEA is very, very easy to hack, and you can actually go very, very far in NCEA without actually knowing a whole lot. So what I'm trying to do is do both. Make sure people actually know things, and also get excellence. And so yeah, even though this is not explicitly needed for NCEA, and you may skip this video, I do believe that it is valuable knowledge. And if you go on to learn physics through, let's say, engineering, in university, for example, this knowledge would be pretty useful. So, with that out of the way, we can start the video. Firstly, voltage can be thought of as a mathematical difference. Now, in maths, when we have a difference, that is usually when we have a minus. So, the difference between 5 and 3 is 5 minus 3, which is 2. So, the difference between 5 and 3 is 2, okay? So, mathematical difference is the minus, okay? So, voltage can be thought of the same way. It's a mathematical difference. If we were to have a section of a circuit, okay? This is a cutout of a circuit, and let's say this point is A, and this point is B, okay? Voltage is the difference in energy of each unit of charge between 2 points of a circuit. So between the points A and B, the voltage across A and B is the difference of energy of each unit of charge between the points A and B. Because of this, you might have heard voltage be called as a potential difference, and therefore as voltage is the difference in energy of each unit of charge between 2 points, the unit for voltage is known as joules per coulomb, okay? Where we know joules is the unit for energy and coulomb is the unit for charge. But more commonly, voltage is known to be measured in volts, which we can denote as capital V. Because like I said previously, voltage is a difference between 2 points. In order for voltage to make sense, we need to know which 2 points we're taking this respect to. So let's say I'll draw another example where we have a circuit like so, and there's a resistor of some kind, and we have points A and points B. And let's say this circuit carries on like so, okay? And let's say at point A, each charge has 9 joules of energy, okay? And let's say at point B, each charge has 4 joules of energy. All right, remember these are arbitrary numbers for explanation purposes. So like I said, voltage is a mathematical difference, meaning we use the minus sign, okay? And so we can say that the voltage across this resistor is 9 minus 4, and that's equal to 5 volts. Or we can say it's 4 minus 9, and that's equal to negative 5 volts, okay? Now, when we say the voltage is 5 volts, what we're saying is that point A, all right, point A has 5 joules more energy than point B, okay? When we say we have negative 5 volts, what we're saying is point B has 5 joules less energy than point A, okay? So, as you can see, both mean the exact same thing, they're just written out differently, okay? However, even though both statements are correct, there is sort of an ambiguity to this, because the voltage value itself does not tell us which way around we did this calculation. It does not tell us whether we did point A, which is 9, and then point B, which is 4, or we did point B first and then point A. It doesn't tell us which way around it is. All we know is that the energy has changed by 5 joules. We don't know which way it has changed, okay? In order to get rid of this, we accompany every voltage value with a voltage arrow. And our arrow always points to a potential rise in voltage, okay? So in this case, if we were to point the voltage in this direction, we can see this is when we have this scenario right here, okay? Because in this scenario, like we said over here, this is when point A has 5 joules more energy than point B, and so this is a rise in voltage, okay? And so this is 5 volts. However, just as correctly, we can also point the arrow in this direction, okay? That's also correct. And so this will be our negative 5 volt scenario. However, I just said previously that our arrow always points to a potential rise. So then how come when we have negative voltage, how come we are still able to point it in the negative direction? Well, what we can say is that the voltage potential at B is a negative 5 volts higher than the voltage potential at point A. And so if something is negative 5 volts higher, that just means it's 5 volts lower. And so therefore we get the same meaning right over here. Okay? Now, once again, this knowledge is not needed for NCEA specifically. This is merely for background knowledge. You can perfectly pass the exam, even get excellence in the exam without actually needing this specific knowledge on how voltage works in a circuit, okay? But like I said in the intro, what I want to do is make your knowledge more unified and more concrete so that you actually have an understanding of what's going on and you're not just memorizing answers, okay? And so if we just do a quick example right here where we have a node, let's call it A, and then we go through a resistor, and this is point B, and we go through another resistor, and this is point C, okay? And let's say the voltage across this resistor is negative 3 volts, and the voltage across this resistor is negative 2 volts, okay? And so what I want you to find is the voltage across the entire thing. So you can give that a try. Now, in order to solve this problem, make it easier, we know we can just flip this arrow and say that's 3 volts, because we know negative 3 volts with a voltage arrow pointing down is equal to 3 volts with a voltage arrow pointing up, okay? And same thing, this is equal to 2 volts pointing downwards. And so as you can see, we have 3 pointing up minus 2 pointing down, and so we have 1 volt coming up. There we go. All right, and that's all for this video on the fundamentals of voltage.